Hello students, how are you all? After a long time, huh? So, the students, today this video is basically on the topic. You can see the name of the topic, Newton-Raphson method. Yes, the topic name is Newton-Raphson method. It is including your syllabus in this unit 2. In the college, before your internal exam, we have discussed about the bisection method from this same unit 2. And now the next topic is today is Newton-Raphson method. We will discuss what is the formula of this method, how the formula is derived, what is the conversion rate, the error for this method, and how to solve the problems, which is most important for you for your exams. That is how to solve the problems. So why Newton-Raphson method I have choose today? Because this method is one of the fastest method to reach or to say to converge to the root. Its rate of convergence is in the form of quadratic. Quadratic means the equations of order 2. So that's why its rate of convergence is so fast. So this method is faster than comparing to your bisection method, or I say regular falsy method, fixed iteration method, second method. Comparing to all that method, this Newton-Raphson method is faster. So let us first of all discuss this method geometrically. How? Okay. Suppose I'm drawing a two-dimension curve. Can you see the two-dimension curve? Okay. This is your origin. This is x-axis. This one is y-axis. And suppose there is a curve which cuts where this is cutting the axis at this particular point. So remember one thing is that whenever a curve cuts the axis, at which particular point the curve cut the axis, that is the required root of the function. Suppose this is your curve y equals to f of x. This is the curve y equals to f of x, and this curve cut the axis at alpha. Now I will see that, now we will prove that only, that how this Newton-Raphson method formula is generated, how this Newton-Raphson fastly converges to root alpha. Okay, first of all let us draw a tangent. Now what is a tangent? A tangent which moves parallelly to the curve and cuts the axis. This is a tangent I have drawn which to the curve. Now first thing I observe is that, let us once again draw the tangent. Okay, this x-axis, this is the point alpha, this curve is your y equals to f of x. Okay, this is your y equals to f of x curve. Okay, now suppose this tangent touches the curve at the point, suppose this point, it touches the point at this particular point. We denote this point as p0 and is coordinated as x0, f of x0. Okay, and this point where the tangent cuts the x-axis, we denote this point as a1. And we suppose that the distance between this from O to A1, distance is x1. That means this point is nothing but your x1. So first of all, the thing what we know from here, the basic thing which we have studied in class 10, the equation of a tangent. Equation of a tangent at the point x1 comma y1 is y minus y1 equals to dy by dx x minus x1. This is the equation of a tangent at the point x1 comma y1. Y minus y1 dy by dx into x minus x1, where dy by dx is called as slope. Dy by dx is known as slope. So we will use this equation because here also we have drawn a tangent to the curve. At which point? At the point x0 comma f of x0. Here the equation is at the point x1 comma y1. That's why this equation is in form. Here the tangent we have drawn at the point x0 comma f of x0. So for this particular curve, let us write the equation of a tangent. So the equation of the tangent at x0 comma f of x0 is, see, I'm going to use this equation only. So y minus y1, what was the y1 here? This thing. So here the y1 will be f of x0, and here x minus x1, this is the x1 point. What is the x1 here? x0. But the thing is that about the dy by dx is the slope, or we can say the derivation of the curve. Which curve? This curve derivation. So if I say y equals to f of x, okay, y equals to f of x, and then what is the dy by dx? Dy by dx equals to f dash x. And at which particular point we are finding the tangent? At which particular point? p0 point, that is x0 comma f of 0. So here the slope, that is dy by dx, here for this particular curve your dy by dx will be f dash x0. Why x0? Why the point x0? Here your slope dy by dx will be f dash x0. Why? Because we are finding the tangent at the particular point x0. So in place we are going to write here f dash x0. Okay, so this is the equation of the tangent at the point x0 comma f of x0. Clear? Okay, now the main part of the equation, where this tangent is cutting the x-axis. This tangent cutting the x-axis at which point? A1 point. This tangent line cuts this x-axis at which particular point? This point. What is the coordinate of this point? A1 point coordinate. This point coordinate is, what is the distance we have considered? OA1 as x1. So this distance is x1. And what is the coordinate for this point A1? Coordinate is x1 comma 0. So this is the coordinate for the point A1. So as the tangent is cutting the x-axis at the point A1, so at the point A1, that is x1 comma 0, at this particular point we will put this particular point in this equation. That means at place of x we are going to put x1, at place of y we are going to put 0. The basic class 10 class 11 concepts, nothing else. At the place of y we are going to put 0 because the tangent cutting the x-axis at the point A1 point coordinate is x1 comma 0. So 0 minus f of x0 minus f dash x0 into, in place of x we are going to put x1 minus x0. So that is minus f of x0 equals to f dash x0 to x1 minus x0. Now let us take this derivative here. Okay, so finally what we get after that here, after simplification, taking just side changing them, we will get x1 equals to x0 minus f of x0 by f dash of x0. Got it? x1 equals to x0 minus f of x0 by f dash of x0. Okay, this is for the tangent which we have drawn at the point p0 x0 comma f of x0. Now we will proceed with our tangent procedure. It is clear. This is the point a1. This a1 at the distance x1 comma 0, this point coordinate. Okay, there is a, this point is a0, this distance is x0. Again from here we are going to draw one tangent to the curve. Okay, this cuttings at this point. Okay, you are not visible this thing now. Okay, let us draw again. Just draw the picture again. This picture is, this was your curve. First of all, the tangent, this point is a1, this point was p0 x0 f of x0. This distance was a0 because the distance is x0, a1 distance x1, a0 distance x0. Okay, again from this particular point we are going to draw another tangent, which, oh, what we have drawn here. Again we have to go into the tangent. This is a tangent. This point is p1 x1 comma f of x1. Tangent cut it at this particular point. This point is called as a2. This distance is x2. In a similar way we will proceed again. From here also we are going to draw another tangent. So you can see that in 3 steps. First step, second step, third step, we are very close to our this particular root. This was the root. So we have seen that we have drawn a graph. I'm very bad in drawing, seriously. So now first of all, at the first tangent we had drawn at the point p0 x0 comma f of 0, and that tangent cut it at the point a1. That is the first step. And second step, again we have drawn another tangent which cut its the curve at the point p1 x1 comma f of x1, and that cuts that the tangent cuts the x-axis at the point a2. And again we will draw another tangent which cuts the x-axis at the point a3, and in the same way we proceeds. So what we can see here, the curve, the procedure is from this particular point x0. From x0 we have started our iteration method, and at 2 steps, x1 x2, at 2 particular steps we have reached very close to our desired root. So that's why I'm saying that Newton-Raphson method is the fastest method comparing to that bisection, regular falsy, second iteration compared to that particular method, because the rate of convergence is here at the rate is quadratic. So that's why I first of all say that this method is the fastest one. Now the second thing is that for the first step we have got the formula. What was the formula for the first step? that is for the step A1, we got the formula x1 minus x0 f of x0 by f dash of x0. We got this particular formula for this first step. Now when we proceed further for the step 2, step 3 and so on, we will get a final formula. And what is the final formula for the Newton-Raphson method is noted down carefully. Xn plus 1 equals to xn minus f of xn by f dash of xn. This is a final formula, or you can say the nth formula, nth step formula for Newton-Raphson method. Xn plus 1 equals to xn minus f of xn by f dash of xn. This is a Newton-Raphson method formula. So this is a geometrical representation of this method. And now what are the questions comes from this topic? Okay, first of all, the question comes from the topic is number 1, the proof of the formula, this particular formula proof, number 1. Number 2, rate of convergence. Number 3, I'm just writing that formula what coming for the exam. Okay, so what you have to study for the exams, the main thing, let us come to the main thing. Now first of all, the proof of the formula, that is proof of this particular formula. Number 2, the rate of convergence, that is the Newton-Raphson method converges in quadratic these questions, so you have to prepare for that question. Number 3, the error estimation, and we know that in every particular method there is a error. In the same way for this particular method, that is for Newton-Raphson method, there is also an error, so you have to study for that error also. Number 4, geometrical representation. Now geometrical interpretation, what we have done now, that is drawing a graph, proving the formula, that is known as geometrical interpretation, that also. Now this for this 4 I will send you the PDF, handwritten PDF for this. Okay, and for numerical problem we will make another separate video for numerical problem regarding how to solve the numerical problems, how to do the numerical questions, because that is the main thing, because maximum of the times numerical problems comes or this too comes. So this is all about the theoretical portion of the Newton-Raphson method. The theoretical portion I will providing you the PDF for the theoretical portion, and for the numerical problems there will be another video on the basis of the numerical problems. Thank you.